Let's walk through encryption fundamentals, which are some of the most important concepts you'll need to recognize for the Security Plus exam. Encryption appears throughout cybersecurity because it is one of the primary methods used to protect sensitive information. The key is understanding how data is protected, how encryption works, and when different encryption methods are used. We'll begin with the most basic concept. If a scenario describes converting readable information into an unreadable format in order to protect it from unauthorized access, you are dealing with encryption. Encryption transforms readable data, called plaintext, into unreadable encrypted data, called ciphertext. The purpose of encryption is confidentiality, which means protecting sensitive information from unauthorized viewing. For example, when you send a secure message through a banking application or encrypted messaging app, encryption protects the information while it travels across the internet. Without encryption, attackers intercepting the traffic could potentially read usernames, passwords, or financial information. Now let's move into symmetric encryption, because this is one of the most commonly tested cryptography concepts. If a question describes encryption using the same key for both encryption and decryption, you are dealing with symmetric encryption. Symmetric encryption is fast and efficient, making it ideal for protecting large amounts of data. A common example of symmetric encryption is the Advanced Encryption Standard, or AES. For example, when a company encrypts files stored on employee laptops to protect sensitive company information, AES may be used because it can encrypt large amounts of data quickly and efficiently. The key advantage of symmetric encryption is speed. The main disadvantage is key distribution. Both systems must securely share the same secret key before communication can occur. Now let's transition into asymmetric encryption, because this is where many Security Plus exam questions become more complex. If the scenario describes using two separate keys, one public and one private, you are dealing with asymmetric encryption. Asymmetric encryption uses a public key to encrypt data and a private key to decrypt data. This is commonly called public key cryptography. Unlike symmetric encryption, asymmetric encryption does not require both parties to share the same secret key beforehand. A common asymmetric encryption algorithm is Rivest-Shamir-Adleman, or RSA. For example, when you visit a secure banking website, your browser may use the website's public key during the secure connection process. The server then uses its private key as part of the encrypted communication setup. This allows secure communication to begin without exposing the private key publicly. A common exam trap is confusing symmetric and asymmetric encryption. The easiest way to remember the difference is: symmetric encryption uses one shared key. Asymmetric encryption uses two separate keys. Now let's compare their strengths and weaknesses, because this is another common Security Plus testing area. Symmetric encryption is faster, efficient for large data transfers, commonly used after secure sessions are established. Asymmetric encryption is slower, more resource-intensive, commonly used for secure key exchange and identity verification. For example, HTTPS sessions often use asymmetric encryption initially to establish trust and exchange information securely. After the secure session is established, symmetric encryption is commonly used for the ongoing communication because it is much faster. Now let's connect encryption to real-world services. Secure web browsing using HTTPS relies heavily on encryption. Secure Shell, or SSH, uses encryption to protect remote administrative sessions. Virtual private networks, or VPNs, use encryption to secure network traffic traveling across untrusted networks, such as the Internet. Encrypted email services also rely on encryption to protect sensitive communications. Now, let's bring everything together using recognition patterns, because this is how you quickly identify the correct answer on the exam. If the question describes protecting sensitive data from unauthorized viewing, think encryption. If the same key is used for encryption and decryption, think symmetric encryption. If two different keys are used, think asymmetric encryption. If the scenario emphasizes speed and efficiency, think symmetric encryption. If it emphasizes secure key exchange or identity verification, think asymmetric encryption. If the algorithm mentioned is AES, think symmetric encryption. If the algorithm mentioned is RSA, think asymmetric encryption. The most important takeaway is understanding the relationship between confidentiality and encryption. Encryption protects confidentiality by making data unreadable to unauthorized users. Symmetric encryption provides fast protection using one shared key. Asymmetric encryption provides secure trust and communication using public and private key pairs. If you can recognize those distinctions and connect them to real-world examples like HTTPS, VPNs, SSH, and encrypted messaging, you'll be able to quickly eliminate incorrect answers and confidently identify the correct encryption concept on the exam.